Hi there, I'm Mr. Kemp. So good to see you again. I've chosen to wear my snazzy shirt today. It's my last maths video. I'm really excited, so I've decided as a bit of a celebration, wear the snazzy shirt. So, welcome to the 13th session in the sequence of lessons about equivalencies of fractions, decimals, and percentages. Today we're going to look at examples where both the size of the part and the percentage that the part forms of the whole are missing. You don't need any resources for this lesson apart from something to write on and something to write with. So let's get started. Now, in the previous session, Mr. Whitehead left you with these questions. So let's have a little look through them. So the first one, so far, Adam has read 180 pages or 60% of his book. How many pages are in Adam's book in total? So the answer for that, of course, is 300 pages. I hope you got that correct. The next questions are ratio tables. So the first ratio table, you've been given 40% is 28, but then 100% and 10% are both missing. So the values are 70 is 100% of the value, and 10% is 7. Okay, and the next ratio table, we've been given 15%, but we haven't been given 100% or 5%. So let's see if we can work that out. Well, 15% is 60, so 100% is 400, and finally 5% is 20. Okay, so I hope you got those correct. Now, he also left you with a challenge, asking, can you create your own problem like number 1 using 40% as your known percentage part? Well, there are lots of possibilities you could have put for that question. Here's mine. I've put, so far, Bev has watched 10 minutes or 40% of her program. How long is the program in total? So there are lots of different possibilities you could have put for your question, but as long as you've put 40% as your known percentage, well done. Okay. So let's dive straight in. Have a little look at this bar model. Now, I'm thinking of a number. Okay. 10% of my number is 15. Okay. Can you see that represented on the bar model? 10% of my number is 15. There's the whole, which we don't know yet, but there is the bit that we do know, 10% being 15. Now, what's the number I'm thinking of? Pause the video and see if you can have a go yourself. Okay, how do you think you've done? Well, we can see that we know that what 10% of the whole is. We also know that there are 10% in 100%, don't we? So if we multiply this value by 10, we can find 100%, which is 150, because 10% multiplied by 10 makes 100%, and 10 multiplied by 15 gives us 150. So the number I was thinking of was 150. Okay, we can also see this, can't we, on a double number line. Okay, so we've got the 15 marked out, and we can see that 15 multiplied by 10 is 150. Okay, and I know over the previous sessions you've been looking a little bit at ratio tables as well, so we can see that on a ratio table as well, can't we? 10% is 15, so 100% multiplied by 10 is 150. Fantastic. Now I'm thinking of another number. 20% of my number is 15. What's the number I'm thinking of? Now, think back to the last slide where we multiplied our known percentage by 10. Can you see what we would need to multiply this percentage by? Now, pause the video and come back when you've had a go. Okay, how did you get on? Well, we know that there are 5 20% in 100%, don't we? So we can multiply our 20%, which is 15 in this case, by 5. We also know that 20% is equivalent to 1/5, don't we? So we would need 5 1/5s to make 5/5 or 1 whole, just as we would need 5 20% to make 100% or our whole. Okay, so if we multiply 15 by 5, we would get, yeah, of course, 75 would be our answer. Okay, now can you see what happens when the value of our part remains the same? So our part is 15, but the size of the part changes in relation to the whole. Okay, so on the last slide, 15 was 10% of the whole, and this time 15 is 20% of the whole, and our whole is smaller, isn't it? Okay, because the same amount forms a greater percentage of the whole is smaller than in the previous example. Now, we can also see this on our double number line, can't we? Okay, so we've got 15 being 20% of our whole. We would need to multiply that by 5 to get our answer of 75. And we can also represent this on our ratio table too. So we know that 20% of our whole is 15. So 100% of our whole is 75. Okay, we've multiplied our 20% by 5. Fantastic. Well done. You're really keeping up. Keep going. Okay, this time I'm thinking of a number again. Now 25% of my number is 15. What's the number I'm thinking of? Again, pause the video and come back when you think you've got the answer. Okay, do you think you got it? Well, what would we need to do on this occasion? Well, we can see that 25% of our 100% is equal to 15. Now, how many 25% would we need to make 100%? 4, of course. So we would need 4 lots of 25% to make 100%. It's the same as a quarter, isn't it? Because 25% is equivalent to 1 quarter. We would multiply 1 quarter by 4 to get 4 quarters, or a whole, just like we would multiply 25% by 4 to get 100% or a whole. Okay, so the answer to 15 multiplied by 4, of course, is 60. Okay, and again, we can represent this on our double number line as well, can't we? Okay, so we've got 15 there, representing 25% of our whole. Okay, and we would need to multiply that by 4. Okay, can you see why we need to multiply it by 4? Because 4 lots of 25% make 100%, just as 4 1 quarters would make 4 quarters. Okay, and our answer is 60, represented on our double number line. And again, we can represent that on our ratio table. We should be quite good at representing things on that, a ratio table now. So we know that 25% of our whole is 15. So 100% of our whole would be 60. Okay, so 3 different ways of representing the same problem. Now this time I'm thinking of a number. 25% of my number is 30. What's the number I'm thinking of? So can you use anything from the previous slide to help you? Pause the video and we'll come back when you've got an answer. Okay, do you think you've done all right? Let's have a look then. So in the previous example, we had 25% as well, didn't we? So what did we do? Yeah, we multiplied that by 4, didn't we? Because we know that 4 lots of 25% give us 100%, just as 4 lots of 1 quarter give us 4 quarters or 1 whole. Okay, so just as in the previous example, we need to multiply 30 by 4, don't we? Now we know that 3 times 4 is 12, of course. So we then know that 30 times 4 must be 120. Okay, because we can unitize. And again, we can show this on our double number line, can't we? Okay, so there is 25%, again, sitting 1 quarter of the way down our number line. And 25% of our whole is 30. So that must mean once we've multiplied that by 4, that 100% of our whole is 120. Okay, and finally, again, we can see this on our ratio table as well, can't we? Okay, we know that 25% of our whole is 30. So 100% of our whole, once we've multiplied that 30 by 4, is 120. Okay. Now, I'm thinking of a number again. Now, 75% of my number is 90. What's the number I'm thinking of? How do you think we could solve this problem? Pause the video and just have a little think and see if you can come up with any way that we can find the whole. Okay. Now, in the previous problems, we've been able to multiply the percentage and its value by a number to get to 100%, haven't we? However, this is not going to work for this problem, is it? We can't efficiently multiply 75% by a number to get 100%. Okay. Now, what could we do? Well, I can see that I can divide 75% into 3 equal parts, each 25%. Okay, so I've divided 90 into 3 equal parts, 2, which represents 30 for each of those equal parts. Okay, now I can see that I've got one part missing. So I've got one part here, one part here, one part here, and here I need another 30, okay, or another 25%. Okay, now here we go. There is that missing 30. Now we know that 90 add 30 would be 120. Okay, we know that 9 add 3 is 12, so of course 90 add 30 would be 120. 120 is the whole. Now, in this example, we can't subtract from the whole, can we? Because we didn't know what the whole was. Okay, so can you see how we've had to break down that 75% into more manageable percentages, in this case 25%, okay, and then build back up to our whole. Whereas in the previous examples, we could just take our part and multiply it by something to get our 100%. Whereas in this case, we've had to break it down first before we then multiply it up, okay? Or in this case, add on our extra 25% or 1/4. So yes, my whole is 120. Okay, now I'm thinking of a number again. Now 25% of my number is 80. What is the number I'm thinking of? Do you think? Well, it's just like in the previous examples, isn't it? I've got 25%. I can multiply that up, can't I, to make 100%. Okay, I know that 100% is the same as 4/4, and I just need to take my 1/4 and multiply it up to make 4/4. Okay, or 25% to make 100%. So I would just multiply that by 4. Okay, so I've got 4 lots of 80. I know that 4 times 80 is 32. So 4 times 80 must be 320. Okay, I can unitize. I can use what I already know to find the answer quite efficiently. Okay. Now I'd like you to have a look at this problem. Using what we know so far, how could you approach this? Now it says, I'm thinking of a number. 30% of my number is 75. What is the number I'm thinking of? Now, could we multiply that 30% by something to get 100%? It's going to be quite tricky, isn't it? What representation could we use? Now think back to the previous examples where we had to break down. So for example, in the 75% question, we had to break that down, didn't we, into 3 lots of 25%. Now, could we do something similar in this problem? Now, if we use a bar model, we can see that we can work backwards to an easier percentage, like I'm seeing 10% before we build back to 100%. Okay, so pause the video and have a little go at solving this using a bar model. Okay, go back to the problem before last if you've forgotten how to do it, and when you come back, we'll have a little look at it together. Okay, how did you get on? Now, let's have a look at how we could approach this problem. First, I would draw my bar model. Okay, so this is nicely drawn for me already, but I would draw my bar model and I would show 30% marked out like this. You can see it's just a little bit before 1/3 of the way down my bar model. Okay, now I know that 30% is 75, so I can divide this by 3. I'm going to divide it by 3 because I would like 3 lots of 10%. Okay, and I know that 75 divided by 3 is 25. It gives me a whole number to work with. Okay, so I know that 10% of the whole is 25. Now I just need to multiply this by 10 to find 100%, don't I? Okay, so here are all my missing parts. Okay, so now I've got 10 lots of 25. I can easily multiply that 25 by 10. And the answer is, yeah, that's right. Of course, 250 is the correct answer. Okay, so when I was thinking of a number, the number I was thinking of was 250. Okay, now your practice activity today is to have a look at this problem and using a bar model, work out the answer. So the problem says Molly is doing a long distance walk. So far, she has walked 14 kilometers. This is just 4% of the total distance. How far is Molly aiming to walk? So I wonder what you would do to solve this problem. Would you choose to multiply the 4% by something to get to 100%? Or will you break that 4% down first before we move on to 100%? We've looked at 2 different ways, haven't we, today? We've looked at questions where it's very easy to multiply our known parts up to get 100%. And then we've looked at problems where this is a little bit trickier, isn't it? We've had to break it down first into an easier percentage. So we've worked with 25% and 10% so far, haven't we? And then we've multiplied that part up to get 100%. So I wonder which way you're going to go about it. I'd be very interested to see. But what I would do is try and use the most efficient method to get your answer. Okay, so remember, the most efficient method is the one that gets you the answer, but gets you the answer in the quickest way with little effort. Okay, now you've been really just fantastic today. You've listened so well. I wish I could see you all and meet you all, but this is very odd, isn't it? Okay, but you've done a fantastic job. I know you have. You've taken part fantastically. Okay, I hope I get to do this again very soon. I get to see you all again very soon. But so far, you should be so proud of yourself. You're nearly at the end, and I hope you feel that your maths muscles are growing stronger each year. I know they are. I hope to see you all again very soon. Keep up the great work. Okay, so for now, bye.